Hey everyone. I was looking at these gravity problems and I was realizing there is a much easier way to solve these than I showed you originally. So I'm going to show you kind of a mathematical shortcut that will make solving these problems easier. And I'm going to do two different versions. I'm going to do a college prep version, which is this one in one dimension. And then I'm going to do an honors version down here in two dimensions. So before, I was saying we need to find the force between those two first. And so I said to do that, we find the force between 2 and 4, and that would be equal to G times 4 times, actually we were saying it's going to be equal to G m1 m2 over r squared. And then I said that was equal to 6.67 times 10 to the negative 11, and then we have the 4 and the 2 over 2 squared. And that totally works. So if you got that, awesome. You don't have to make any kind of changes. However, when you do it this way, you get this scientific notation because of that right there. And there's actually an easier way to do it. Instead, what I'm going to do, we're going to go back it up. I'm going to leave that as G. So what I'm going to do is I'm going to call this G, and I'm going to plug in the rest of the numbers like that. And so then I get a force of 8G over 4, which is 2G. Okay, I'm going to leave it just like that. I'm not going to multiply out the G yet. I'm going to do the same thing for the other one. Okay, I'm going to do between the 6 and the 4. So I'm going to leave it G 4 times 6 over 1 squared. So between the 6 and the 4, it is 24G. Okay. So when I'm looking at this, I could actually redraw it. Let's redraw it in blue. So I have my 4 kilogram object in the middle, which is what I had there. And it's got two forces pulling on it. It's got 2G pulling it that way, and it's got a force of 24G pulling it that way. So I need to make sure that this is negative because it's pulling to the left. So the net force would be minus 2G plus 24G, which is 22G. Okay, now I'm going to plug in the G. So now I'm going to do 22 times 6.67 times 10 to the negative 11 to get my value of 1 second, let me plug it in the calculator. I get 1.47 times 10 to the negative 9. That's my answer. So if I did it the other way, it totally works out. I think this way of plugging the G in at the very end, it keeps all my numbers very reasonable. I have like a 2 and a 24 and a 22 and an 8. It keeps all the numbers very reasonable, and then plug in the scientific notation at the end, and it makes it much simpler than trying to plug in the scientific notation at the beginning and then having to carry through the scientific notation all the way through the problem. So if this way makes sense, go for it. It should make the problems much easier. So let's do an honors example for those of you in honors. We're going to do the same thing. It's going to be the same problem. I'm going to swap this out. So it's the same problem. It's just in 2D. So I'm going to do the exact same thing. I'm going to say, well, let's put it down here. Let's put it in red. Okay, the force between 2 and 4 is basically going to be the same thing, right? It's going to be g times 4 times 2 over 2 squared, which is what we just found, was 8g over 4. It's the exact same problem so far. Actually, let's make some room here. Let's put it down here. 8g over 4 equals 2g. Okay, and then let's do, let's do 6 and 4. So I'd have, basically this is the same problem as last time. Has the same numbers, they're just at angles, but we're not dealing with the angles yet. So this would be 24g. Okay, so if I redrew this picture, I redrew the first picture again. I redrew it right here with the forces pulling on it. So I'm going to do the same thing down here. So this one, I have my 4g object, 4 kilogram object. It's getting pulled two ways. It's getting pulled this way with a force of 2g, and it's getting pulled this way with a force of 24g. Okay. Right, because that's basically the same picture, right? But instead of using distances and masses, I'm drawing the forces acting on that 4 kilogram object. It's getting pulled both those directions. And so now it turns into a problem like the Newton problems. So now we're going to break this up. We're going to have this vector at 2g, and it's at a 30-degree angle. And we have this one, which is 24g at a 45-degree angle. And we're going to find the force in the x direction. We're going to find the force in the y direction. So the x direction is the hypotenuse. Let's get rid of this line. Let's move this over a little bit. Times cosine of 30. And then our y would be 2g times sine theta. Okay, and we'll do the same thing here. This will be 24g times cosine of 45. And this will be 24g times sine of 45. So I'm doing the same process, but instead of using the scientific notation, I'm just carrying it through. So I'm going to do 2 times cosine of 30, and I'm going to get 1.73. I'm going to do this one, and I'm going to get 1 g. 24 cosine of 45 gives me 16.97 g, and this is also 16.97. Okay, the next step is to get the signs correct. So this one is going left, so I need to make sure it's left, and it's going down. And this one is going right, so that's going to be positive, and it's going down, so that's negative. Okay, so my next step is to find the total So the total in the x direction would be negative 1.73 g plus 16.97 g, which is something negative 1.73 plus 16.97 gives me 15.24 g. And I'm going to do the same thing for my y. I have negative 1g minus 16.97 g. So my y is negative 17.97 g. All right, the next step is to find the total force, or my net force, and that is the square root of my x part and my y part. So I'm still leaving those g's in there. And I'm going to plug it in. I'm just going to pretend they're not even there. 15.24 squared plus 17.97 squared. In the calculator, I'm not even putting the g's in. I'm just ignoring them. So I'm just kind of carrying them through the problem. And I get 23.56 g. And now I'm on my final step. So now I'm going to do 23.56, and now I'm going to put in my scientific notation. And I'm going to get a very small number. Let me try that one more time. I have 23.56 times 6.67 e to the negative 11. I get 1.57 times 10 to the negative 9. So it's basically the same thing, right? The only exception is, instead of plugging in my 6.67 times 10 to the negative 11 at that point, where I get the scientific notation, I have to do sine and cosine of the scientific notation, I'm basically leaving the g's in. I'm basically pretending they're not there, and I'm just carrying them through. So they just kind of float through the problem. And then when I get to the end, then I plug it in right there at the very end. All right, and this totally works. Like right here, we have g squared and we have a g squared, but then we're taking the square root, so it gets rid of it and just turns it into g. Mathematically, it all works out just gravy. All right, so if this way makes sense, it'll definitely speed up things. It'll make things easier. If this method does not make sense, stick to the old method, plug it in at the top. Both methods will give you the correct answer. I just think this way is a little bit easier. All right. Thank you very much. I'll see you guys soon.